Thank you, Alexander. Great to be presenting on this topic. So yeah, in today's session, I'm going to be praying to the demo gods because I'm going to try and do this mostly hands-on, and I've got quite a lot to get through and show you. So yeah, let's get straight into it. So Workspace is available in beta today, and what I'm hoping to do in this session is tell you how you can take an idea, some raw data, some concepts, and kind of model them as a graph and do some initial nodes. Start querying it to derive some insights, and then think about kind of iterating and expanding on that. And then finally, kind of looking at some of the ways you can visualize and explore the graph within Workspace. So to make this a bit more relatable, especially for me, residing as I do in the UK, I've maybe wisely or unwisely, I don't know, I've chosen to take a look at UK politics data. So yeah, the kind of comedy that you see going on the animation on the left there. So looking at some open source data, so I kind of had an idea. I wanted to see kind of what existed open source. So there are a few projects that exist out there, some kind of independent and all related kind of government data. There are some projects out there like Public Whip in the UK that try and make information about politicians, members of parliament, and the things they vote on, the divisions, the technical arcane term for it, and the policies and the houses they kind of sit in and the parties they represent, all available. And then there are also other websites like They Work For You, which is like a website that kind of gives you, amongst other things, a view of what kind of interests politicians have in terms of what people pay them to support them and that kind of stuff. And then we have a registry of companies in the UK that kind of helps you understand the companies that maybe give money to politicians, what kind of business they're in with industry codes. So in this, I was just kind of hoping to see, taking the seeds of an idea, some data, and kind of trying to see if some of the things you read about in the press that kind of a lot of people have heard of, regardless of the country you're in, conflicts of interest, what they look like in graph form. So a big disclaimer at the bottom. Nothing here has been verified for accuracy. This is kind of a rough and ready kind of exploration of the data, but it was pretty interesting to do. So starting off, this is Public Whip data that I was able to get my hands on. So this is a dump of a relational database that is fairly rich, but it's pretty complicated, as you can see from the image on the right. You've got information about MPs, members of Parliament. You've got their names, their MP IDs, the parties they represent, the areas of the country they represent, roles they hold, things they vote on, including the kind of links between the MPs and the things they vote on, and a whole host of other data. So how do you go about starting this on this problem with Neo4j Workspace? So I'm going to show you kind of this rough process here that I went through, and I didn't want you to kind of sit through loads and loads of kind of several minute long data loads. So I've kind of seeded all the data in the project here already. And I'm opening, as you just saw there, I was opening up from my OR instance that I've created, and then straight into Workspace, which is available for everybody as of today. And what I'm going to do in here, I'm going to switch first of all to the Import tab, and I'm going to go across and get some of that data that I was talking about. So some of this open source data. Let me just switch across to that. So here in Data Importer, I can drop in my flat files and I can start thinking about sketching out my graph model. So some of the things I was talking about, you have members of Parliament, and you have, let's see what else we have on the left-hand side. So we have, for example, in the MP file down here, we have the house that they sit in. So in the UK, it's the Commons or the Lords, and then there's a party that they represent. So you might name this relationship member, and sits. They do a lot of sitting down when they represent people and they do their debates, and they're, say, a member of a party. And then the process here is very much about mapping this flat data. Here I'm exclusively going to use this first file that you saw on my previous slide to do that. So you're going to have PWMP, select from there the MP ID. I'm going to bring in their constituency because technically it's the person that is the name, and people get elected, for example, a member for Hackney, North and Stoke Newington, an area of the UK. I think that's everything we really need for the member there. So here it's kind of automatically chosen an ID based on a strong clue here to uniquely identify that MP. And then on this side, we can do the same process with this file, but this time for the house. So we're going to say, okay, we want to know how that person, or rather that member, what house they sit in the political party. And here the import tool is automatically mapping in for us how that relationship gets defined from the MP ID to the house in the same file. And we can do the same thing for the political party. So we can map in the party here. And it's doing lots of convenient things for us here, kind of choosing, we've only added one property, that's probably the ID to be used. And in the import tool, we can do a quick preview without committing any data, just to see whether this is taking shape and kind of doing what we expect. So we can load in here. We haven't loaded lots of properties on the members. But we're seeing some of the titles come through there, but we can see there are lots of members that sit in a certain house. So the Commons is the biggest house in the UK, and we can see the Labour Party here, and we can see some of the other parties kind of on the fringe here, maybe the smaller parties, the Scottish Nationalist Party, Plaid Cymru, I think this is, and Sinn Féin, Ulster Unionist Party in the Republic of Ireland. So that's pretty cool. So we can do that, and we can run the load, but I'm not going to show you kind of the load of here because I've loaded this data already, but I'm going to show you what the more extensive mapping looks like for this data. And I'm just going to bring back in the files here for completeness. And we can see how here we've got a fairly extensive model where, I was mapping out this part here earlier, but you can repeat the same process using different files to get quite an extensive model to load your data through. So that's pretty cool. That's a nice starting point. So here I've done all this without writing a single line of code, and you can then go and start querying that data. But there are, the tool I've shown you is designed to get people going, and it's not necessarily going to cater for every load case, but that's not a problem because we can break out to kind of other ways of loading data that allow us to kind of do more complex loads. So part of the model that we kind of couldn't quite load here with this tool is the policies and the policy sets, just because of the way they link with the complexity. So I'm just going to show you through how some of that stuff was done here, where we can load in, and I saved this here, and I'm going to run through this pretty quickly because I don't want to go into tons of the detail on it, but how you can do things like to make the load run more quickly, create an index, or we could have created a constraint on the policy and the thing that uniquely identifies it. Simply from referencing the file, we can make this available on the internet to kind of link into it, create policy nodes with those IDs and set the properties from those files. So, this file down here, I believe this is the one. And then this is where it gets a bit more complicated, creating an index kind of on a compound here that we can then use to do the match against things that are already in our model. So, for example, the divisions that we already loaded, and then link those into the policies and create new supports relationships. And this allows us to do some kind of quite cool stuff subsequently. So that's all done in here. We can see that I've got quite an extensive set of stuff loaded here already, and that data is loaded in to our model here. So we've now got some of these parts of the model. So the other part is loading in the policy sets. Now, when I was kind of working on exploring this kind of, bootstrapping my graph project for exploring UK politics data, there was also kind of a set of, the policies are the things people vote on. So I can probably show you a few of those things, show you what they look like. So you've got some policies like people who are, things that are votes for people who are, for example, against the Iraq war, and kind of more detail on there. But these are quite granular, and there are quite a lot of these. So it's pretty nice to be able to roll this up to a higher level to some policy sets. So kind of in this project, it was pretty complicated how these policy sets came up and together, and there was a lot of information about how people edit wikis to come up with definitions of how all that works. But in scraping the web in this project, we were able to come up with some pages that showed how to do that. And I was able to scrape from the web some kind of simple data structures that showed how particular policy sets with names were mapped to particular divisions. So this is a really nice example where I could scrape a basic set of data structures from the web and use this to create some nodes that kind of give me more clarity and higher level kind of abstractions in my graph. So I can run this in Workspace, and this sets a number of parameters that are ready for me to use to create new nodes that summarize some of the information in my graph. So the next stage here, kind of looking through all of those policy sets, creating kind of higher level policy sets that make kind of a part of set relationship. So you can imagine here, there's a high level policy set that aggregates some of these individual policies, so you can get a higher level view of what people are voting on. So I could rerun that. It would take a few seconds, but being as it's been run already, I'm not gonna do that. And then we could do some potentially interesting things here. We've got kind of a good core of our model in here, and we can start looking at things like how many different policies saw different votes on these divisions. So members of parliament voted on divisions that support policies, and then in turn, I've commented this bit out, are parts of sets. So we could start looking at how the policies and sizing them by the number of votes they've had on them, and also the policy sets, if I was to kind of comment this back in and then start summarizing on PS for policy set. So I've run this stuff already to kind of save, but primarily to save myself making mistakes, but also to kind of in the interest of speed. But if we look here, the relationship I was creating, or rather the nodes I was affecting, were the kind of part of set, so policies and part of set. So we can do a quick visualization in Bloom here, and if I type the name of the relationship, so part of set, I think we can see, that relationship coming in there, and we can start to explore what some of that looks like. So I've pre-configured this here, again in the interest of time, but I've used some rule-based styling within Bloom to size the nodes based on the number of votes they had in. Now there's one node here, if I zoom in a little bit, that I know is not super useful. It's like the catch-all, it's called summary. So I'm just going to dismiss this one and get rid of that. And then kind of zoom out and see, what are the biggest things that are, important in UK politics over the last few years. So I can see that the biggest policy set, the aggregating, is foreign policy here. And we can see that, by far the biggest node in terms of policy topic is European integration, so AKA Brexit, and something that has very much occupied UK politics for a very, very long time. So that's pretty cool to get that level of view here. So what's next? So there's loads of cool analysis you can do here in terms of looking at the positions that people hold on these policies as well. So I'm going to kind of cover this also super quickly so I can show you some of the final things too. But you could start exploring the graph and kind of, let's look at the against relationship that I'm creating here. We can start, let's decompose this query and let's just comment bits of it out for a moment. So let's return just the first part of this query. Let's return just one line of this. So we're looking at people elected members of parliament that voted on particular divisions, the things they vote on, and how they support a particular policy. So I'll just run that and we can see that pattern here. So we can see, and actually I ran this earlier and I knew that this person didn't actually vote on any particularly interesting policies as the first result. So let's just skip through the first 1,000 rows and look at somebody who might vote on something. Actually, let's skip another 0 and see if we get anything more interesting. So here we're getting somebody called Irene Adams, who was elected to Paisley North. Maybe I didn't find something super interesting in this example, but they're kind of voting on council tax, and this is kind of a policy around somebody who kind of observes conservative values. Now it's worth saying that all these policies are created by a community, so some of them roll up to that higher level policy set, some of them kind of just are kind of very niche topics, and this is probably one where they're kind of correlating and doing analysis on particular niche policy views that you can view in the data set. But what you can do, looking at these kind of patterns of here, is you can see that if we look at here that this MP voted no to this particular division, and we can see here that this supports relationship. If somebody votes A, which is kind of the old British arcane term for the yes that we use in Parliament, then that means they support this policy. So that person voted no, so they're generally not in support of that kind of policy. And we can use that information to kind of create some kind of shortcuts in the graph to kind of cut out some of these parts of the path. And we can create position against relationships, and we can create, on the other query that I've got here, position for relationships. So we can start to see how people support or don't support particular policy topics, and aggregate on the relationships the number of votes on that. So I can show you some examples of the relationships created here. So for example, position against, there's a particular, let's have a look here, there's a particular MP returned, and you can see their positions with a number of votes on a number of different kind of policy topics like pro-Euro, one nation conservative, so on and so forth. And not shown here, I've kind of pulled in some of a kind of a further level of aggregation at the party level using a similar principle where you can view people's parties' positions on policy. So aggregating it up to the kind of the party level. So let's try that in this view here. I'll clear this scene and look at position on policy, and let's see what comes back here. So we've got quite a few parties in here. I'm just going to manually select, let's zoom out a bit, and I'm going to kind of manually select a few of the kind of smaller parties because I want to look at, say, focus on some of the bigger UK parties in this analysis. The two biggest being, let me just dismiss those two, those few, dismiss those nodes. There's my option. Can't quite see that. Let's try again, dismiss, and then let's dismiss a few of the others in here. I could have probably written a more sophisticated query to just bring these two things in, but I'm going with brute force here. So here are the two main parties in the UK party political system, and here we've kind of run in some metrics that also I'm not showing the detail of, but kind of looking at the proportion of people who vote for a particular policy on one party versus another, and representing that proportion as a thickness of line. So a thick line means supportive, a thin line means not supportive. And it probably doesn't surprise anyone that the nature of kind of two-party politics in the system shows that if one party is generally for something, another is generally against it. So you get thick lines on one side, thin lines on the other, and they're generally quite polarized on most topics. I did a further analysis of this kind of offline, and I think the only thing political parties generally agree on is kind of mass surveillance of people. So it's kind of an interesting takeaway. So that's kind of doing that further analysis on what people kind of tend to think about different policy topics. But going back to my initial theme of what I was trying to explore, I was also trying to look at kind of the kind of interests, as it's termed in the politics, the interests that the MPs have to register. So they're required by law to kind of show donations that they receive from different entities, be they individuals or companies and that kind of thing. So here on the left is an example of from Ms. Diane Abbott, the one that comes at the top of the alphabetically sorted MPs, an example of something that she reports from back in June this year. So again, I won't show you the kind of detail of the import config. It's pretty much the same thing I showed you before, using data importer to load in those interests. They had records of the people and the categories, so we could link them in based on IDs to link the interests into the people we had in our existing graph and some categorization. But we could then run some very, very basic entity extraction on that. And for this, I used Google Cloud Platform to do this. There are probably much cleverer and more sophisticated ways of doing this, and I kind of ran no tuning on this. So there are quite a lot of false positives in this. But it's good enough kind of just extracting some initial insights. And I can show you the kind of thing that came out of this. So I think I've got a GCP entity kind of link here. And we can see that, let's take this one over here. There's a particular interest here where a member of parliament, which I would see if I kind of linked out from this node, received complimentary tickets for a rugby match from the Welsh Development Agency. And there are other interests in these kind of things, where they've received them from breweries or betting companies, or there are interests in the financial domain that are probably even more relevant. And we can see how the entities have been extracted here from this. So the interesting thing is we have locations, but we have the organizations pulled out here, and that forms the basis for some of our subsequent analysis. So the final step in this analysis is looking at companies' house data, because the last chain in kind of my analysis was thinking, well, okay, we've got now a view. If we go back to our graph, we've got MPs, we've got the things they vote on for doing interesting voting pattern analysis. We've also, not shown in this graph here, but we've loaded in the interests and how they link to those people. But what we don't have is an understanding of, the kind of the companies that they've got interest from, what kind of categorization they have. So are they a financial institution, or are they a brewery that sells alcohol? All kind of people who are interested in lobbying politicians for certain kinds of, influencing the way they might vote on topics. So the last was loading the company's house data and writing some kind of basic lookup functionality to try and match nodes across that. So again, this is just kind of like a quick idea of how to do this, but we got some I got some good initial results from doing this, so I thought they'd be interesting to share and show how you can use some of the capability of Workspace to do these kind of things. So here, quite simply, once the nodes for the companies were created, we ended up with these termed here companies house nodes that have got quite rich information on companies. We've got addresses, we've got company names, and importantly, we've got some category codes here. So that's super interesting.
Can you zoom in a little bit on this one?
Yeah, I can zoom in a tiny bit. Tell me if you can see a bit better there. But we've got things like, this is an information technology company, and we've kind of got that classified here. So the next stage in the process was kind of creating some full text indexes on these nodes, so that we could then search against them and kind of match them up to the organizations we found mapped into the kind of financial interest that these politicians may have received from those companies. So I'll just show how that works very briefly. This is it's a lot of boilerplate in this query to kind of get around the fact that this is a kind of using a kind of full text Lucene based type index. Just making sure we kind of exclude certain characters. If I run this, I'll get an error because it's expecting parameterized imports. If I kind of replace, for example, here, so I work for Neo4j. I've got a vague recollection that our office is on a Union House or Union Street or something. So if we set that parameter and then rerun this query, we should be able to look up on the company's house data the kind of matching entity. So we found Neo4j UK Limited with the address line Union House, and we get some kind of scores around how good that matches from matching here. So that's great. And then, so with that, what we've been able to do is then create some kind of similar company name relationships. So within our data set, and bear in mind that our entity resolution is not always perfect here. So we do have some kind of, or rather entity extraction is not always perfect. We do have some kind of false hits. But for example, here from the data, from the extracted entities, we've got the national Wind Power UK, has a similar company name to UK Wind Power Limited, and GMB Yorkshire gets a match with, okay, this one's maybe not quite so good, but we see we've got some kind of matches here for the Welsh Development Agency that we saw on one of those earlier, mapping to similar terms there based on address and kind of name. So we've got something we can kind of start to work with here. So the final stage in kind of this step was to kind of look at, as I was using, I probably did this over a course of 2 or 3 days, kind of messing around with the data and working out what to do. Kind of the next stage in my kind of trying to prove whether there was anything interesting I could do here was working out that if I look at the industry classification codes for here, if I look at some of the examples, let's look at this code here. This is actually going to find all the some of the distinct values here. So it's going to take a little while to run because there are something like 5 million different company entries in here, but they're super, super granular. And there are, I think from recollection, about 1,000, 1,500 of them. So one thing we could do then is just scrape the web to look for, okay, well, what do these codes mean at this really granular level? And we can kind of create some kind of simple statements in here, some kind of matching statements to say, okay, well, if the code starts between 1 and 3, then it's something to do with agriculture, forestry, and fishing. If it's this range, then it's manufacturing. So we could quickly run this to kind of add a new property to our company's house nodes. And that means that we have like new properties now on these nodes that kind of have a much higher level of aggregation. So you can see that node property populated here. So this then enables kind of the final step of the analysis. So the query here is not super complicated. Let me just clear the stream view so you can see a bit more of what's going on here. So the final step is building on everything, or a lot of the steps we've done before, finding the organizations that I know will kind of reference on the interests that have a matching company where we know the category, finding people that are companies that are involved in manufacturing, and then starting a new traversal again, going back from those organizations, finding out their interests and mapping back to the people who recorded those interests, and also looking at the parties they belong to. So kind of finding those kind of whole trails of going from the companies that are in a particular sector, finding the interests that they map to, and then the members of parliament that kind of received kind of those payments from those industries. And then we've done some stuff here to kind of cut out some of those paths. So we can create a virtual relationship between, here in this example, the kind of party-person pairs in these relationships, because we're not necessarily interested in the full detail of a person was elected a member of parliament for a particular term and did this. Bringing the members of parliament nodes in would be kind of too much information for our visualization. So this is kind of creating a virtual node just for the purposes of doing the visualization. So here I've kind of run this against the manufacturing industry just to see what gives. And if I run that, we start to get a graph of kind of all the parties and the kind of interest they receive in pink here. So these are the parties, Conservative and Labour. And I've picked this one mainly because it had a tie back to my main image at the beginning, where you can see here that there are a lot of members of parliament in a certain parliamentary term. You can see a kind of a cluster of this company called JC Bamford Excavators Limited. So JCB, the people who build diggers, and probably don't expect them to be crashed through polystyrene walls, but you can see that there are a lot of members of the Conservative Party receiving various financial interests for their campaign. So it's stuff that we know about, but it's really interesting to see it in graph form. So equipped with this kind of query, you can then for example, set this up in Explore. We could clear this scene here and look at setting up a search phrase for this. So we could create some saved Cypher, and I'm going to save myself time by just showing you the one I set up previously. So this is exactly the same Cypher that I was just showing you in the query tab, but this time it's parameterized by that industry code. And we're giving the search phrase here, what do party interests coming from a particular industry look like, is the question. We're giving it a lookup for those section codes that we created for the company, just so we can kind of ask those kind of questions and quickly see in a visualization. So there's probably a slightly more efficient way of doing this in terms of lookup, because this is probably going to scan the full kind of 5 million nodes each time. But just for a quick illustration, let me show you this in action. So we can kind of have this search phrase here. What do party interests coming from industry? And then it's kind of looking at what different section codes exist in those nodes and allowing us to kind of choose one of those industries to save us kind of having to go and do a query and look those things up ourselves. So here we can see a list of all the different codes that we got from. So I looked at one with, I think it was manufacturing before, but we could look, for example, at financial activities and then run that query. And then here we're going to see, if I let that kind of all settle for the visualization, we can see kind of clusters of nodes. And I could probably do a better job of coloring these. This is not a super well set up perspective, but you can see a Conservative Party here. And you can see, if I zoom out, you can also see kind of Labour Party over here. And I think from having looked at this previously, I know that some of these companies that have been classified have not been done completely accurately, because I was doing this as a quick exercise. So this GMB I know is actually a union, so I can kind of I'll discard that as a false positive. And then if we kind of zoom out of this view, we can see that really the most activity centered here in terms of interests is maybe not unsurprisingly, if you think back to kind of my first slide of a particular party being, bankrolled by certain kind of industries, you can see that, companies involved in the financial and insurance industries tend to have more of a propensity to kind of provide effect sponsorship and interests to this party in government. And we can just have a zoom in here, and not all of these are perfect. We can see HSBC, Europe, Arab Bank, IPGL, who I assume, and kind of assume most of these, Royal Bank of Scotland, are all kind of financial institutions providing funds to certain kinds of party, which is much less noticeable kind of on this side of it. So anyway, that concludes my kind of run through of all these things. So if you want to check out Neo4j Workspace yourself, it's available today for all new Aura users. So you will now see it as your default option within Aura. That's for self-serve. So if you're creating a free instance or a professional instance, you'll see that there as your default option. You can still switch to see the individual tools from the user profile menu being shown here. So bear in mind that's still available. If there is not complete feature parity, for example, especially in query with what is in browser, but we're making quick progress to get there, and there's some much improved functionality within query versus browser in terms of performance and for example, some of the parameter setting functionality I showed you there. And yeah, for existing Aura users, you can just opt in. I think we'll leave it for you as default, the individual tools, but you can go in there and switch out to use Workspace. And if you're an Aura Enterprise customer or self-hosted, you don't have access yet, but watch this space for further announcements. So thank you for listening. I couldn't resist not ending with this clip for nobody, for people who don't know what this is. This is our Prime Minister before the current one, where there was a competition to see if she could last longer than the shelf life of a lettuce, and she didn't make it. I think 10 days was the record. So anyway, I hope you enjoyed learning a bit more about how you can use Workspace to kind of bootstrap your graph projects. And yeah, hopefully you weren't too disheartened by the things you already knew from the political sphere in graph form. That's it from me. Back to you, Alex.
Very cool. Thank you very much, Gregory. I think that was very interesting and very cool to see the new workspace as a demo and overview. So I hope everybody liked it as well. I hope virtual applause, please, for Gregory. I think we have a bit of time, so we can maybe squeeze in one question. Alec has one. Can you view an existing data model from the workspace? So how would it work if you are already having something ready, and can you explore it there as well?
Yeah, so you can continue to use, we have in the query tab, we have the call db.schema.visualization command, which will give you a view of your existing data model, that may have been created by whatever form. So I didn't show that in my presentation, but yeah, you can absolutely still do that. And we have some roadmap items looking at being able to do that in the import tool as well. So being able to kind of generate a view of what that model looks like in the import tool, in case you want to kind of load stuff against that additional kind of model. But yeah, absolutely, you can do that today.
Cool. All right. Yeah, I think with that, thank you very much, Gregory, for presenting and for showing this.